All right, good afternoon everyone. Let's go ahead and take a look at curve properties part 2. What we're going to do today is we're just going to analyze this graph and see whether or not we can conceptually understand what's going on with the first derivative and how that relates to the analysis of a particular function. So let's just take a look at this graph here. Notice that it goes up here, goes down, goes up, goes down, goes over here, goes down. And let's just go ahead and just make sure, as a review, that we know for a fact what all of the values of f prime of x are over this entire interval that we have. So let's say, for example, if we're talking about here, we know that there's going to be a horizontal tangency, so that's why at this value x sub 1, we're going to go ahead and say then that the first derivative is actually equal to 0, again because of the fact that the tangency at that point is horizontal. There's going to be three other places where that happens. That's right here, right there, and also right there. So notice that we have these x sub 1s, x sub 2, x sub 3, and x sub 4s. At those particular values of x in the domain of the function, we know that the function's first derivative is equal to 0, and therefore all of these points here are called stationary points. Okay, let's take a look at what we have now. If we go ahead and take a look at this part here, notice that the slope, or the instantaneous rate of change of the curve, is actually going to be positive. So we know that all of these values over here are all positive for the first derivative. And then it starts to decrease here. The function is decreasing, and if the function is decreasing, we know that the slopes of the tangent lines are all negative. So we know that this is negative, negative, negative. Okay, and then if we take a look over here, again, it becomes positive, 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 positive. When we come down here, all of these are negative. So let's take a look again. Negative, 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 and negative up to that point. So we have negative, 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 negative. And then when we come here, notice that again, it's all negative. Okay, so there you go. That's how we can go ahead and take a look at the sign values for f prime of x. Now what we're going to do is we're going to introduce some new language here, and it should be pretty apparent based upon the graph what we're referring to. And the terminology that we want to look at initially is maximum and minimum values of the function. Now when we're talking about the maximum and the minimum values of the function, we're referring to the y values of the function, okay, or the range values. So if we were to go ahead and take a look at this particular graph, where are the y values the greatest? Well, it's obvious that it's here, and it's also here. So what we would do then is we would call this a local max, and that also a local max. So I'm going to say that the local max values are located at these particular x values. So notice the difference. The maximum values are determined by the largest y values of your function, but we're going to actually report them as the x values that gives those y values. Okay, so the local max is at x is equal to x sub 1 or x is equal to x sub 4. Oh, sorry, 3. Okay, let's take a look at the local min values. Well, the local minimum values are here. Okay, so we have just this value here. So that's going to be at x is equal to x sub 2. Now what is this global max thing? Now the global max and the global min, as opposed to the local max or the local min, is going to look at the whole entire graph and also include the endpoints. The endpoints. Okay, so if I was to go ahead and take a look at all the particular values of my function, all the y values of my function, the global max is actually going to be the maximum y value for everything if I consider all the values of my function. So, of course, if I was to go ahead and compare these local maxes, then I'm going to say that since this maximum here is actually larger than this maximum here, then I'm going to say that the global max is actually going to be x sub 1. So x is equal to x sub 1. Now, if I go ahead and take a look at the global minimum, again, what we're doing is we're looking at all the minimum values. So the minimum values would be this value here, but I also need to go ahead and take into consideration the endpoints of the function. So notice that if I was to compare this value here, and that value there, then of course this value over here, let's go ahead and associate that with x sub 5. That value there would then be the global minimum. So x is equal to x sub 5. Okay, now there's one other point that we haven't talked about aside from this other endpoint, and it's this point at x sub 4. Now why is x sub 4 going to be interesting? A separate category from the local min and the local max, and that's because if we go ahead and take a look at how the sign values are for f prime of x about that stationary point, notice that there isn't any change. So in this case, there's a change from positive to 0 to negative. In this case, it's from a negative to 0 to positive. In this case, it's a positive to a positive 0 to a negative. And that's why we're going to consider these 3 points here to be either maximums or minimums locally. Okay, in addition to globally, but we'll consider that after we look at all of the values. Now the only difference is that when we come to this value here, notice that it goes from negative, the values of f prime of x, from negative to 0 to negative. Notice that we cannot consider this value right here to be either a maximum or minimum of the function, because of course to the left and to the right of it there's values that are either going to be larger or smaller than that particular y value. If we take a look at the other situations, that's not the case. This is actually going to be the largest y value for just this part of the function. This is also going to be the largest part of the function for that interval. This is also going to be the minimum value for the function on that interval. So what we're going to do then is we can't call this a maximum or minimum. We're still going to call it a stationary point because f prime of x is still going to be equal to 0 there. But we have to call it something else. And we're going to call this a horizontal inflection point. So the horizontal inflection point actually takes place at x sub 4. Okay, and there you go. That's how we can use our curve properties. That's how we can use the first derivative to now go ahead and analyze the function in such a way where we can actually talk about the local max, local min, the global max, the global min, as well as determining whether or not we have a horizontal inflection in the curve itself. Okay, so based upon that information, I want you to go ahead and answer this. It's either true or false. If f prime of c is equal to 0, then there is a minimum or maximum at x is equal to c. Okay, is that true or is that false based upon what we've done here today? The second thing that I would like you to answer is this. It says if there is a minimum or maximum at x is equal to c, then f prime of c is equal to 0. Okay, you have everything that you need in order to answer these two statements, answer whether it's true or false. You can do that using all the information that we just had here. So take a look at this section and we'll work on some of the problems in class when we go ahead and discuss the curve properties part 2. Alright, give it your best shot and see you next time. Bye-bye. And this information